Welcome to your packet on functions. You should be looking at the cover page titled Functions. We're going to be discussing what makes an equation or a relationship a function. We're going to be taking a look at linear functions and nonlinear functions. There are two kinds of linear functions: linear and proportional, and linear and non-proportional. And you're familiar with those two. But we'll also be taking a look at nonlinear functions, such as a quadratic, a cubic, an absolute value function, and an inverse function. Now turn the page and let's take a look at the back of your cover page. The back of your cover page. On the back of your cover page, we have the official definition of a function. It states, a function is a special relation in which each member of the domain, the x values, is paired with exactly one member of the range, or the y values. But what does that mean? Well, let me give you an example. Please take down these notes in the open area on this page. Let's take a look at a basic t-chart, and we will plug some values into an equation. Your x values are known as your input values, or your domain. Your y values are known as your output values, or your range. We're going to determine if the relation represented by the equation x plus 4 equals y is a function. The x values we input into the function can have exactly only one member of the output values known as the y values. Let's imagine that we're going to put in the number 1, 2, 3, and then at the end we'll put a 1 in again. Imagine your function is like a machine. For every value of x that we input into the machine or the equation is going to output a y value. Each x will be increased by 4. For example, if we input the number 1 into this equation, it will take that value and add 4. Our output value is, of course, 5. If we take the 2 and do the same, it will add 4. Our output value is 6. And a 3 input into the machine will produce an output value of 7. Each x value going into the machine has exactly one member of the output values. Even if I put the number 1 back into the machine again, we will get an output of 5. The machine is working beautifully, and each input value has exactly one unique output value. So, this relation represented by this equation is indeed a function. But let's see a case where it's not a function. Let's take this situation for example. Let's pretend that the machine is a mystery, but we input the number 1 into the machine. It goes into the function machine and the output is a 3. Now we take a 2 and we put it into the machine. And the output value associated with the 2 is 4. We put another 1 in, and we're expecting an answer of 3. However, the machine outputs the number 7. That's a problem right there. The input value of 1 cannot have 2 different output values. And let's say we put a 2 in. We're expecting an output value of 4, but if we put it into the machine and it outputs an 8, we know that this relation is not a function because the 2 can't have 2 different output values, one of 4 and one of 8. So this relation, represented by the machine, is not a function. However, this relation up here, represented by the equation x plus 4 equals y, is definitely a function. Your input values can have only one specific output value. Another way to think about functions is to listen to the story about what your favorite color is. You can see that 3 different relations have been given to you at the top of this page. Story 1, Story 2, and Story 3. Let's take a closer look, and maybe this will demonstrate to you exactly what a function can and cannot be. In story number 1, we have the domain with 3 different students. Student 1 said that their favorite color was blue when asked. Their output value is blue. Amber is only allowed to have one favorite color. Tim, the second student, has exactly one favorite color, that's red. And our third student has exactly one favorite color, which is green. Each input has exactly one unique output, such as this numerical chart. Each X only has one favorite. 1's favorite is 10, 2's favorite is 11, and 3's favorite is 12. In this case, you would say, yes, it is a function. Let's look at situation number 2. Again, 3 different inputs, 3 different students. Student 1's favorite color is blue, student 2's favorite color is blue, and that's okay because each student can have the same favorite color, and student 3 likes green. This is a function. What would that look like numerically? Well, something like this. If you input 1, its favorite is 7. If you input 2, it can also have a favorite of 7. And if you input 3, it can have a favorite of 7. All 3 can have the same favorite value, which is 7. So this is also a function. However, let's look at case 3. Case 3 is not a function. If you ask student 1 their favorite color, they cannot have 2 favorite colors. You're only allowed 1 favorite. So, because there are 2 different outputs for this one input value, this is not a function. How does that look with a table of values? Well, something like this. If you have an input of 1 and an output or a favorite of 5, you can't input the 1 again and have a different favorite of 6. Right there, 2 different output values for the same input is a problem. That relation is not a function. So, no, that third case is not a function. This concludes the introduction to functions. Please take down all the notes and let's move on to the next page.